Binary search. Everyone knows what it is and how it works, but literally no one knows how to code it up. Isn't that a crazy statistic? I mean, is it left equal to mid or mid plus 1? Is it left less than right as the exit condition? It's too much. It's too much. However, as the only person in the entire world who knows how to implement binary search, I'm here to demystify it for you. Before we start binary search, we want to define the search space, which is the range of values we want to search in. We can define the search space using a left pointer and a right pointer. From here, we define a middle point, and this is the point we're going to use to figure out where we need to search next. So for instance, if we know the midpoint value is less than the target or the value we're looking for, that means the target is somewhere to the right. So we narrow our search space toward the right. The inverse is true if it's on the left. That means we narrow our search space towards the left. You're probably fine up to this point, but now is where we dive into the parts of binary search that make even seasoned engineers want to end it all. When we want to move our left pointer, for instance, we need to pick between either left equals mid or left equals mid plus 1. To understand which choice to make, we need to ask ourselves, do we want to include the midpoint or exclude it? If we set left is equal to mid, we include the midpoint. If we do mid plus 1, we're going past the midpoint, so we're excluding it. The only time when we really need to exclude the midpoint is if we're absolutely certain that the midpoint is not the answer we're looking for. Otherwise, if it's possible the midpoint could be the answer, then it's important to include it as we narrow the search space. Now let's talk about the exit condition. This is when we should conclude our binary search. Our two main options here are, do we conclude when left is less than right or when left is less than or equal to right? Let's think about what happens in either situation. When left is less than right, binary search concludes when the two pointers meet. Whereas when left is less than or equal to right, the two pointers need to pass each other in order for binary search to conclude. I actually found that you can get away with using the first option for almost every binary search implementation. I find this option easier to work with since we know that when binary search concludes, both pointers will be pointing at the same value, which makes the return statement a little bit easier since we can usually return either pointer as our answer. However, it's worth noting another big difference between these two is that we don't actually end up evaluating the final value of binary search when we use left is less than right, because when the two pointers meet and there's one value left, the while loop exits. We exit the while loop before we even get a chance to look at it. Whereas when left is less than or equal to right, we do end up evaluating that final element before binary search concludes. Now, if you're anything like me and you still just want to use left is less than right for every binary search you implement, then you can avoid this problem by evaluating that final element after binary search is done before you return anything. Now, there's just one more thing I'd like to talk about: the dreaded, career-ending, infinite loops. Now, before we talk about any solution to this, you need to realize that to understand the enemy, we must first know when the enemy shows. We need to know this analogy isn't working. In order to solve the infinite loop problem, we need to understand when they occur. Now, a really useful thing to know is that you can identify if an infinite loop is going to occur in your algorithm by evaluating a search space of two elements only. So let's think about why this happens. Two elements is an even number of elements. When we set the mid pointer, or when we calculate the position of the mid pointer, where do we end up positioning it when there's two middle elements? We end up positioning it on the left one because of rounding down in the midpoint calculation. Now imagine what happens if your binary search algorithm had left equals mid somewhere in its logic. That's right. Infinite loop. In this situation, when there's two elements, the left pointer gets set to the midpoint, and the midpoint will then get set to the left point, causing this infinite loop where they both get set to each other. How can we avoid this? The way I like to do this is to bias the mid pointer to the right whenever this happens. We can just do this by adding 1 to our mid pointer calculation, effectively biasing it to the right. A useful rule of thumb here is that whenever we're doing upper bound binary search, we bias the mid pointer to the right. whereas in most other binary search cases, we can just keep the midpoint calculation as is. Okay, I hope this all gave you a much better idea on how you can handle these weird little intricacies of binary search, and I hope this makes your next interview that much easier. However, there's so much more to talk about on the subject of binary search, and we go through all sorts of tips and tricks and example problems in our new Coding Interview Patterns book, which I'm glad to say is now available on Amazon. Thank you very much for watching.